Algebraic thinking, equations, and functions. Algebra thinking begins in kindergarten as young students represent addition and subtraction with objects, fingers, mental images, drawings, and sounds. Acting out situations, verbal explanations, expressions, or equations. Elementary students are capable of understanding and applying significant algebra ideas. This includes strong connections between arithmetic and algebra. In middle school, students begin to study algebra in more abstract and symbolic ways, focusing on understanding and using variables and expressions and equations. Algebraic thinking is used to generalize arithmetic, to notice patterns that hold true in algorithms and with properties, and to reason quantitatively about such things as whether expressions are equivalent or not. Algebra must be presented in ways that students see it as a useful tool for making sense of all areas of mathematics and real-world situations. Looking for generalizations and sets of problems can be in kindergarten with decomposing numbers and continuing through early grades as students use strategies to add and subtract. Place-value relationships. Fundamental to mental mathematics is applying place-value concepts. The way the number system is structured. Consider 49 plus 18. Would you add 1 to 49 and to subtract 1 from 18 to get 50 plus 17? Or would you add it in your head mentally? Or would you take away 2 from 49 to get 20 plus 47? A slight shift in how arithmetic problems are presented can open up opportunities for generalizations. For example, instead of a series of unrelated computation problems, consider a list that can lead to discussions of generalizations. Like 3 times 7 is what? 6 times 7 is what? Some students might notice that 3 is twice of 6, so that 6 times 7 is twice this of 3 times 7. Students need to notice equivalent expressions as they engage in their work with numbers. For example, consider number talks with young children where the teacher asks students to tell if 3 plus 7 equals 7 plus 3. A student might explain that both sides add up to be 10, so they are equal. Students might start to notice the cumulative property of addition, that a plus b is equal to b plus a. Although students may understand the commutative property of multiplication with whole numbers, they may not recognize that the property also applies to fractions. Ask students if this is true for fractions. Is it true for all types of numbers? All numbers? Noticing generalizable properties and attempting to prove that they are true is a significant form of algebraic reasoning and is at the heart of what it means to do mathematics. Odd and even numbers provide an excellent content for exploring structures of the numbers.